Hello, everybody. Welcome to day 2/4 of PASS, depending on when your journey started. My name's Jay. I'm a Principal Program Manager on Azure SQL Data Warehouse. I've turned my phone off. I trust you've all done something similar with yours. And I'm a former PASS board director and SQL Bits organizer, as well as someone who has been very active in the community and have worked a lot with PASS in the past. And so I would certainly encourage everybody to take a moment and make sure that you contribute to the PASS board directors meeting, PASS board director elections, because those people represent you at the highest levels of the organization, but also take advantage of the things that PASS provides throughout the year, especially the local opportunities with your user groups, chapters, and SQL Saturday events. I think there's a pretty amazing achievement that the group actually provides all of that for you for free. So this, as I say, a little bit about me. My day job is largely involves things like data virtualization. It has involved working on Azure SQL Data Warehouse for the longest time. But most recently, the Azure Arc and Azure Data Services running on Azure Arc are what consumes my time these days. Yeah, you are more than welcome to reach out to me, but let's leave Facebook where it is. Okay, so what are we going to be talking about in today's session? We're going to be talking about data virtualization and some end-to-end scenarios about how you can think about data virtualization, how you can think about using it in your environments, and taking and making the most of it for yourselves. So how many of you have actually used or tried the data virtualization features in SQL 2019? Okay, there's a small number of you. I'm hoping that number will grow significantly as you learn about this technology and are able to kind of use it in your environments. Because actually it does change quite a bit about how you can do things and how you choose to use them. How many of you have used a link server before? There we go. That's much more like it. So all of those hands should be looking at this technology and thinking about how they could maybe use this in a different way. Right? So let's start with what the data virtualization fit is, because that's the start. The start is actually understanding what it is and where does it fit in terms of a solution. So the first thing is to kind of, if you like, contrast data movement technologies and data virtualization. So the first thing is in a movement or a data pipelining type event. What are you doing? You're building and constructing an ETL pipeline. What does that mean? It means that you are connecting to a source and copying that data through the pipeline, maybe doing some stuff to it before you land it in another location. Okay? Typical scenario of that is obviously going to be like your data warehouse type scenario. But what you're doing at that same time is you are duplicating that data and you are fixing up that data. Nobody has ever kind of come to me and said, I have built the perfect data warehouse and never had to put any kind of data quality hygiene things into my data warehouse. That has never happened and is unlikely to ever happen. The other thing that happens when you're doing that data movement is that you may also be able to do some extensive modeling. Okay, you tend to be shaping the data in a different way. Okay. Now, you contrast this with data virtualization. In the world of data virtualization, we're doing what I consider to be a query time data pipeline. So you make your connection, you know where your source is, but actually everything else happens at query time. It is not a constructed timeline, right? So the data that you hit on that query is the data that it is at its freshest at that point. The second thing about that is that we are taking a single copy of the data because we're not duplicating it, or we don't have to duplicate it. We're querying it at source. Okay, so there is a difference. We are not introducing additional cost in that level. The third thing is that we actually rely on data quality at source, okay? So that is a significant difference. It also affects how you might think about how you might choose to use this in different scenarios. And then lastly, in data virtualization, we are able to do things like you can do in a regular query to shape data, like you might do in a view. But that is limited compared to what you would do in a constructed pipeline where you may be doing some very, very significant work. So what are some of the challenges that you might see or face when looking at data movement? Well, first thing is there is a cost, and those costs are not always financial. They also are in time of implementation. Okay, so there is a significant engineering effort when you build out data pipelines in an ETL scenario. Generally speaking, if you think about it in terms of a table per source, you might have, say, for example, in an industry schema like PPDM, for example, as one I've worked on in the past, has 1,200 tables. That could mean that you're running 1,200 pipelines to actually populate and manage that at the very least. Okay? Now, also in terms of cost, we have the notion that you are going to take a copy of that data and move it into another location. Typically, we think about ETL as a 3-stage process: extract, transform, load. Either way, it's a duplication of the data, maybe triplication, maybe more, right? So that's the first challenge with data movement, is it does have a latency cost as well. Right, so now we get into the velocity. It is an integrate then query scenario, i.e. you don't know what you've got until you've built the pipeline and spat some data out at the other end. That pipeline may take time, right? It's your ability to query the data is when you have landed it on in the target in the shape that you want it. And that may be longer than you desire. So there is latency on the query. It also means that you have to build everything before you can actually do any type of initial query. What does that mean? It means that things like data exploration is harder, right? Because you actually have to do the integration, work out whether you have the right data, and then go and target it. Security. If I duplicate the data, then I have an increased surface area and exposure to that data, right? Because I now have 2 copies of that data. And now I have to think about that from both a GDPR perspective, but also from a security perspective. I have to extend my security model. So I have I consider that to be a fractured security model over a single piece of data, right? My single view of that customer is now multiple physical copies of the customer. So in a world of GDPR, I now need to make sure that I can trace exactly where I've sent my customer record, so that if someone comes along and decides that they want to express the right to be removed from your systems, that you can do that confidently. Data quality is always a fun one. It is even more fun when the data quality issue has been resolved in the middle of a pipeline, somewhere embedded in someone's code that has long since left the organization, and we have something that does something that may or may not exist in the future as a problem, right? Now, there is a visibility angle to that. Is also problems at the fact that actually the root cause of the problem has never actually been addressed. And that's an interesting one at an organizational and cultural level. If everybody is fixing up other people's problems down the line, it means that anybody that reads the source data has the problem. And so actually a lot of the time, especially in data warehousing, when I used to work out with customers, we always used to try and push as hard as we can to get the fix in the source rather than the fix in the pipeline, right? And that's where things like data governance have become such big topics of late, because really and truly it's about trying to get organizations to adopt a greater degree of stewardship over their data, that you have basically data governance and corporate data ownership for those systems, and getting the business to take ownership for the data that they generate. And then lastly, you have like the governance aspects, and we've touched on that a bit already. Data governance does actually increase from a complexity point of view with a data movement solution, mainly because you have extra copies of the data around and you need to be able to track all of that, and that just increases risk. So, data virtualization with SQL Server, we offer kind of new solutions, right? So what we're doing is taking the challenge of cost and trying to provide you with solutions that enable you to do low cost of curiosity exploration of data without actually having to move the data, not having to move it at all. You don't have to. Velocity, because you can do self-service prototyping and work on the source data, you can work at a level of freshness that is not possible to work on if you're having pipeline of integration and data warehouse feeds and streams and stuff like that. So there's an ability to get to actual real-time or query time solution. The third one is security, because you're dealing with a single security model, and you will see that we also have, and I will talk about this later when we talk about one of the implementation scenarios, auditing and classification in the box as well, so you can build out robust solutions in that area. And then the last one is one of the things I think we have kind of forgotten maybe a little bit is that we actually enable in SQL Server in the box the ability for customers to develop HTAP solutions. What does that mean? It means that SQL Server is a multifaceted engine and enables you to build analytical and operational kind of reporting out of your transactional systems and deal with source problems at source, right? So you can have things like column store tables and in the same database as you have your operational queries. So you can actually address a lot of these things by building out a mixed kind of solution actually on the source. And that is great because actually what it means is that the more you focus people on the source system, the more you are actually addressing data quality issues at source. It means that anybody reading the data is getting a clean read of the data, and that is a good thing. And then lastly, from a governance point of view, we have things like data classification to help you provide and build compliance solutions in your organization. So what I would like to just touch on now is what we actually have provided and how I think about it. And that is that we provide what's called I consider to be the data virtualization hourglass. And you'll see what I mean as we go through these solutions, is that actually data virtualization, if you look at it, is actually is a multifaceted thing. You've got the ability to connect and read into a central point, but you also have the ability to go from SQL and read out. And we'll see what that means as I go through 3 scenarios that we're going to talk about in the next remaining part of this talk. The first one we're going to talk about is the Enterprise Integration Hub, or the Data Hub. And this is one where we're actually going to use data virtualization technology as a pseudo ETL. And why might we do that rather than just using a native one? Data virtualization can be used for data integration, and there are real reasons why you might do this. The first one is simply a very simple case of performance. If I can actually push a join up into a server-side effect and affect the join on the server side, then that's actually going to be a lot better than maybe streaming all of the data down to the client and trying to do client-side joins. The second one is around transformation. As we've seen in many cases, the data that you have, if you think about in a data warehouse, you have snapshot tables, accumulating snapshot tables, for example, or you flatten a table in machine learning or data in those types of scenarios where you're actually wanting to actually create a persisted data set. Those scenarios are very legitimate scenarios. And in those cases, you can still use data virtualization connectivity to be able to bring the data into that server side and just persist it. And I'll show you that in a second. But I think the third one, which is actually one of the most obvious and compelling, is the notion of historization. data virtualization enables you to be able to connect and read the data as it stands at the time that the source system tells you that data is, right? We can go in and say, the data today on my double-decker is as follows, and this is my product data. And so I end up with something that looks like this, and I can see that I have a weight of 54 grams here for my double-decker, which I can assure to all of those of you who don't know what a double-decker is, it is God's gift to chocolate, provided by Cadbury's. And next time you're in the UK, I can strongly recommend that you stop past the nearest store and pick up one, and not only remember this talk, but indulge in a delicious treat. However, one of the most contentious aspects of chocolate coming from the UK especially is not the great Cadbury's cream egg debacle where we stop using Cadbury's chocolate and using some generic brand, but actually the fact that the sizes of bars change over time. And if I was to go back to the 1970s, my favorite double-decker actually weighed 42 grams. So if I actually wanted to look at this and trend Cadbury's chocolate over time, I would not be able to do that if I was just reading the data in current time. I would have to be able to historize the data. Now, typically, you'll see this in a data warehouse from a dimensional model, right? That's exactly what we're doing. You can't do that in a data virtualization scenario without actually persisting data, right? And so you actually can think of scenarios where actually from a dimension perspective, you might say, actually, I want to historize a table, in which case actually using data virtualization to be able to facilitate that is as a pipeline is completely fine if you're just reading off of a cleansed kind of master file of what the current master looks like. But then you would then use SQL Server, just like you would do today, just to build out a type 2 dimension on that data. Now, you could then use the same pipelining technology to then go after the fact data about sales of said chocolate bar based on weight, and we could then do some analysis about whether or not data virtualization is, whether sales are affected by the weight of said chocolate bar, right? And look at other interesting facts over time. But those facts tend to exist in the source system much more so than, say, for example, current state of reference data. So this is the top half, as I see it, of the data virtualization hourglass. And you can see here that we are connecting and using it as an information management hub or a data hub to be able to kind of connect in and get that data. Okay? And so we're going to use data virtualization technologies and concepts to be able to kind of do that initial snapshotting of data, or even to go on and build additional models. And the three key things that we have here are external objects, database scope credentials, data sources, and tables. And we've talked, you may have seen these in various guises before. I'm going to step through them in a notebook just to be able to help illustrate all of the kind of key little key concepts that exist behind each one of these here. Okay, so what we're going to do is look at the enterprise integration hub scenario and understand what we mean by the top of the hourglass. So let's switch from PowerPoint. And instead move over to a notebook. And let me just see if I can punch that up better. Okay, so what we're going to do now is we're going to run a notebook that is going to start to explain how we build all this stuff together. So I happen to have 3 demos. We're going to go through 3 scenarios. I also happen to have 3 children. So the databases are named after my children, and because that's how I like to roll. So, and I love them all somewhat equally, so they each get a database. So the first thing we need to do once we've created a database is create the master key. And a master key basically is the key that hides all of our secrets and encrypts those for us and keeps everything safe. So there's our master key. And then we're going to create database scope credentials. And the database scope credential is the identity upon which we go and access the remote source. And what I want to make sure that you understand here is, and the reason why I've done it like this, is that we're going to connect to 2 remote sources, and we're going to connect to 2 remote sources in all contexts. The 2 remote sources we're going to talk to are another SQL Server and an Oracle database. And what I want you to see here is that the language we're using in all cases is exactly the same, okay? So you don't need to learn Oracle in order to be able to understand how to deal with all of this stuff, okay? So here is the first thing. So we're going to create our database scope credentials, and there they are. Beautiful. So now we can then say, okay, now we know what we're going to use to connect. We can now go and use the external data source to define it. We're going to use drivers that we have shipped in the box for SQL Server and Oracle. On Windows, we also enable you to install your own drivers and connect to almost anything else that you want. So what we're now going to do is use that credential, and this location is going to tell us where that server is in your environment. So I run that, and there we have our SQL and our Oracle instance. Now, I'm a big fan of schemas, and so in this example, we are going to use 2 schemas to host the 2 tables. And what we're going to use is, for these tables, I've actually using a SQL Server 2019 instance and an Oracle 11xE instance. They're both using the TPCX Big Bench dataset in the backends. So this is an example of the schema for the customer table in Big Bench. And we're going to create what we call an external table to define, if you like, the interface between how we're going to interact with this table. So we're going to create that, and you can see underneath here, right, that we point to the external data source, and then we use the location, i.e. the location here, the database, the schema, and the table name to access that database, right? Now, and there you go, we can see it's here. So now let's go and do the same for our Oracle instance. And you can see that the Oracle table, we're having to be a bit more explicit, and there's a couple of things that you need to know, right? First of all is that we are column binding to Oracle based on the collation and everything. We need to be sensitive to collations across instances and all those sorts of things. We also need to respect everything that is there in the system. So we're using here the schema, the table names, and you can see that they're all uppercase. The other thing is because these character strings come from Oracle, Oracle has defined what those need to be, and we map those as well. But you can see down here, all I need to do is to reference the Oracle data source and then provide the table name, customer, the schema, and then the service, in this case, XZ, that we're accessing. So it's another 3-part name, and you can create that. Okay? Now, one thing just to, whilst we're here, because this is also supposed to be a bit of a 300 level session. You can see I've created it there. Let's go over and add code here. And drop that in. Now this might be something that you're not aware of, is that the schema, for those of you that have used external tables in previous versions of SQL Server, the schema, the table names it was an ordinal-based mapping, and you had to have everything there. That is not any longer the case. So I can do this, for example.
When you said service, can you just go into that a little bit more? You said that XE represents a service in Oracle?
Yeah, the listener, the service ID. So, so the question was, can I explain what the XE service is, and it's just that's the service ID. So now, if I just run this again, you can see that worked exactly fine. So the binding in SQL 2019 is on column name, not on ordinal position. So I can only have to map in the columns that I'm interested in. Okay? But there are things that do matter. Like, for example, here, I have strings that I care about, right? So if I'm going to, what things that you need to care about or think about, okay? So for example, if I take those collation names out, right? And this is something that I'm not sure, every time I show this, some people know about it and go, oh, that's, everyone knows about this. But you can actually do this kind of thing, and you don't need to worry about actually having to do it all in a string. But now we're going to see that actually we don't like that so much. Now, the reason being is that we actually need to be very specific with collations, because you could have, on the other side, two tables with the same name, but if the source system is case sensitive, for example, we need to be able to understand whether you're talking about the lowercase version or the uppercase version. We need to know what string semantics that there are, so that when Wei-Yun is making sure that all of our code actually does a join, that it is a legitimate join, and that we're respecting all of those things. But one of the notable differences, again, in SQL 2019, which is actually great for people, is that underneath that, when we do experience a problem, we actually tell you what the problem is. So here you can see it's quite full because I took out quite a lot. But what it actually says here is the following columns are not specifying the right collation. This is the collation we detected. Now, not only that, this was always a bit of a bugbear for some people in terms of like understanding what the schema should be for that source. And you can see here that actually what we've got here is actually the full schema underneath there. I'm parsing all of the text, but under there is the full schema of actually what we need the external table to be if you wanted everything, and gives you all the column names and all of the data types and all of the collations, and that's what we detected. And so we actually will make sure of all of those things for you, and that makes it easier for you to generate external tables, because you can just look at that context and then just put that in yourself and you would be fine. But in order to avoid ruining my demos moving forward, I'm going to come back up to the top here and redo the original one. And now when I run my query against that Oracle instance, you can see that my partner in crime, UC, for the one of the other PMs in our team, we can identify him in the Oracle data. I just injected him in, and you can see that we can now just query that table as though it is part of the SQL instance, right? And that's just us querying Oracle. Now, once you have that, sorry, we have a question.
Is that nice Oracle, that nice error message just for the out-of-the-box drivers, or is that for other drivers that you may install on the Windows Server? I
believe it will be for whatever we can see.
It is. I've had that work for Spark as well.
Yeah. But that's a great question. Now, going back to our conversation about how you might then want to use data virtualization, even for data integration, is, say, for example, someone asked you to build an ETL pipeline, and you were saying, oh, well, hang on a second, I need to actually want to be able to profile that and all the rest of it. I can create the external data source, and then very quickly, against this Oracle instance, using T-SQL, I've now been able to fully profile that column, that database, and start doing that very, very quickly. I've not actually had to go and build the pipeline in order to be able to understand what the data source looks like, and I can look at the distribution of the values and all those sorts of things just by actually profiling the source. Now, when it comes to doing the actual snapshotting, it's also very simple, right? I can just, this is just my housekeeping step. I can create a schema for my snapshots. As I said, I do like a schema. And then I can just create snapshots of those tables. So you can see here, my syntax is exactly the same, okay? Whether I'm doing an Oracle table or I'm creating a SQL table, I have now created 2 snapshot tables of the data source, and I've stored those in here. Now, obviously, from here on in, I could then go on and create my data, my dimension or whatever, because I have the data locally. But also notice the fact that actually I haven't had to write any different type of code to deal with T-SQL versus PL/SQL because I've accessed Oracle. I've used a top command here, and I've used that deliberately because top isn't natively supported by Oracle. But you can now use that just to be able to access it and be able to run. Game on, right? You don't have to learn anything to be able to profile that data set, run against Oracle, and away you go. Okay? So,
Are there any limiting SQL, like windowing functions and all that are still compatible?
we are limited by what we can do through the driver. But generally speaking, we try and work through as much of that as possible. And we're going to talk about what we can push down as we go forward. Okay? So that's the hub, right? That's the first part of the hourglass, right? Everyone okay with that? Question at the front.
At which level command syntax will be checked? On the source or target?
So that'll be a runtime.
On runtime. So if we use an Oracle syntax, it will be checked on Oracle side.
No, you don't use the Oracle syntax. You use T-SQL. We will convert that through the driver, send that down against the source, and we'll deal with it at that time. So that is the first part of our the first half of the hourglass. We're now going to move into the second half of the hourglass once I have answered this gentleman's question.
So if you wanted to get around using the driver, can you do a subquery or something else to get around?
You can write your own queries, right? What we will parse that query, yeah. One of the things that we are doing is we're making very opinionated choices about the fact that we're using SQL Server's optimizer to work out what best to push down, how best to resolve that query. What you can do to influence, which is a great question, is can you influence the query? So you can rewrite queries in different ways. The other thing you can do is actually apply statistics, and you can create statistics on external tables to actually guide the optimizer in more direct ways. Okay? So you can you have a lot of control. And actually, for a lot of that sort of stuff, one of the things that is most common is things like the need for like multi-column statistics and things like that, which you have to do anyway, right? So now you're just extending that paradigm slightly. So if you know, for example, that you are going to have a where clause that's highly selective, you're going to be there. Now, the other flip side of this is, if you're talking to Oracle, for example, and that Oracle column isn't indexed and you have a big where clause on it, right? Then you may see that you can only go as fast as the query will go on Oracle, right? So, and that may be quick and it may not be, right? So let's just take it out. I'm going to show you some other stuff in a second. So, Virtual Data Hub. The virtual data hub is the second half of the hourglass. So the second half of the hourglass, you may see come up in a number of different kind of industry type requirements. And you may have this in your organization. How many people here have one data warehouse and one data warehouse only in their organization? Exactly. Most people, the reality is that you have either geographical boundaries. How many people work in multinational organizations that have different organizational kind of group level reporting? Right. So that's the first one, is the geographical boundary scenario. And that geographical boundary could also be closely linked to an organizational boundary, and it also could be a technology boundary. All three of these scenarios provide the scenario where you have essentially multiple things, but then someone on the board says, I want to see a single dashboard that brings all of this together. And then you are faced with the choice. Do I build another data warehouse that sits on top of all of these as the kingmaker? Or do I do something like a virtualization scenario and cap my topology with a data virtualization scenario that can just reach down and get whatever the latest state is of that for the reports and pull that back up to the top, right? And that's the virtual data hub scenario, okay? So what we're going to do now is go back into into the second scintillating notebook for next demo. I haven't yet. There's no difference, right? We in those scenarios, what you would do if you were having like an Oracle and a SQL, right, and you were trying to do a join across those two, any of the where clause predicates we would push down. The join would have to be done on the server side or in SQL. Yeah. What we would also do though is only obviously pull over the columns that we needed, right? We do all of that, right? So the way I used to think of it is if your table's like this, the goal of our predicate push down is to do that. So it is not just a question of this, it is also this for the filters, and then it's pre-aggregation, right? So you think about it in those three steps, life gets very easy. Okay. Okay. Please go ahead and ask the question. I'm not ignoring it. I'm just opening the next one.
When you add external table, can you add computed column?
Not today. But you can create a view over the top of the external table that has the computation in it. And that's how I would do that anyway. Because you don't have that control over the source. Sure. So we make cost-based decisions. So there are even scenarios where if there's a predicate, if we think it's just faster for us to just go and get the qualifying rows and then do the filter locally, we reserve the right to do that. Okay. Yeah. So this is the fun part of SQL Server being a declarative system, right? You get to ask the question. You don't get to plumb the calculator to tell me how to do it, right? That's Wei Yan's job.
Is limitation for external table to modified source removed, or we still have only read-only snapshot, just like retrieve data?
Today we support read scenarios. We're not doing write back. Okay, so whilst we were doing that, I was just moving through a couple of the necessary prereqs that we just discussed, which is the data scope credentials and now our external data sources. So now we're in and this time we're going to create organizational schemas. We're going to have one for APAC and one for EMEA. And as I said before, we're running exactly the same tables in both locations. So in this case now, I'm going to have my APAC web click streams and my EMEA web click streams, which is my fact table. And now I'm going to create the same for item, right? Both for APAC and EMEA. So now when it comes to doing the virtual data hub for group level reporting, we run the query. Okay? And you can see that I'm just doing a union across the two data sets to be able to provide group level reporting across those two things. Now obviously, because I'm using exactly the same database, you can see that the numbers are exactly the same. But you can see the first one's from APAC, the second one's from EMEA, right? And that's by design. So now let's look at that, because that query didn't take wasn't quite as quick as I'd have liked. So let's see how we might think about troubleshooting this from a distributed data virtualization scenario. So here in the DMV query, we have the first major DMV that you need to know, which is DM exec distributed requests. And we ally that with DM exec SQL text to actually see the query itself. Now, little top tip here for those of you that are interested in these sorts of things. You can see the query took just over 5 seconds. Now, what I did when I hit the query, one of the things I did, because I knew I wanted to do this, was I put a little comment here, -vdh query. So I know what I'm kind of looking for in the text, and I can just see that that's there. So if I have lots of different things, if I just know I'm going to go and do this for troubleshooting, this is actually quite handy. So now I have what's called my query. My query is a query execution ID. It stands for query ID, and is a logical concept. One of the things that we can do with data virtualization is what we call scale-out reads. And so I use that as a logical query ID across a distributed system. So now if I put that quid in here, and great, we have a dropout. Hopefully that came back. So you can see I can now move on to the next DMV, which is called request steps. So now I'm going to break down how we actually work through that query. And actually, we have a number of different execution steps that we're taking when we ran that query. And they're all available here. So I'm going to have to drop this down for a second. The key things you want to look at are actually I'm going to have to do this not zoomed in, I'm afraid. The key things you want to look at here are where are we spending the time running that query. And you can see that I have 2 external shuffles in that query because I'm hitting 2 data sources, right? And you can see that I have the first one, 3714 seconds, and the second one is another DMS move, which is 800 and something milliseconds, right? So, but I know that this is the same thing. They've got the same record count. And you can see here that the movement here is an external shuffle, which is how the data gets brought into the system. And you can see that one's taking longer. But the question is which one? Was it the Oracle one or was it the SQL one? Which one do I need to go and fix? So what I do is I actually run against now I know that it's a data movement elapsed time question. I can take my quid, use that against DMV DM external work, I'll try and zoom it back in. And you can see that of those two steps, there's the Oracle one and there's the SQL one. And if I am able to get this, I'm going to have to, the zoom is interfering. You can see that the Oracle one took 3.6 seconds, the SQL one took 7:38. So I know immediately that the thing I need to go and speak to is the Oracle system, and it could be that I'm missing some query or whatever. In this scenario, the reason for this disparity is actually because I'm using like the free version of exe, the free version of Oracle, so for the demo. So I have to do, you don't have all of the features in that product, right? So it's not quite as quick. So now let's get into the notion of push down. So to be able to do the filters and those sorts of things. Question?
Sorry, can you speak real quickly to optimizing external tables? Like say you have to do a join locally, and you can read a sorted data set in and then join on them. Is there the ability to let them know that table's sorted, or to add keys or things like that? Or
no, so you can add stats to that table. And the way to think about stats in this context is it's like a super lightweight index, right? So it's telling us. The thing that now you know that, what you would then do is say, okay, I'm now going to run this query against that source. I can now go and actually look at that source and profile it. But what I actually have here is I even have in this statement here the actual full query. So I can actually go here, click on that, right? And what I've been here, if I go and fire up, for example, some like T-SQL formatter, all right, we use this one. There you go. So now I can actually see exactly what was sent down, and I can actually look at what was actually positioned. So I know what all the columns are, right? And then it's just a question of going and speaking to that DBA maybe, or whoever it might be, and just saying, hey, look, we're getting a slow performance with this query. Can you help us out? We need to work out whether we need to tune something here. So it's that kind of simple. The other thing, though, I don't know whether you noticed, I think I can go back to zoomed in here. Here, in the syntax of the external data source, we actually have a concept called push down on and off. And this is because in some cases, a source system might not want you pushing queries, pushing computation down. Because what you're actually doing is saying, I'm going to use your computation to be able to do it. Now, they might say to you, no, we don't want you to do that, right? And so you can honor that by using this push down statement and sending it to off, right? Now, there are consequences to that, and we're going to go through that, and I'm going to just take you through that quickly. So I'm going to set that to off, and now I'm going to use my APAC item table, right, here with the off statement. Okay, that's just run back on. I've just recreated that table, nice and easy. And now I'm going to rerun that query, and you can see I've got my little off key trigger here. And now you can see that the query is taking a lot longer. And this is against the SQL instance, right? This isn't against the Oracle one. This is the one that was running in sub-second. And you can see that that's just taken a lot longer to run. Come back. So when I actually query that, you can actually see why. So I get my quid. I put that in here to go and look at my steps. Oh. To look at my steps. And you can see that because we aren't able to push the join down, because of that push down, I'm going to have to come on. You can see, hopefully, that there's actually, even though we were only querying one source, we had a join, and so now we have multiple movements to go and get that data, okay, here and here. Now, what I want to just call out here is that this is the item table, and I know that because of the row count. The second one is I'm having to pull the full table because you told me not to push down, and I'm having to pull more data. So you can see that actually I'm now pulling more data than I would have otherwise wanted, right? It's because I switched the push down off. Now, I did that at that level. Now, that is the all-encompassing one. And I can see that those two queries are there because also when I run the external work scenario, I can see that they were both there. They're both against the SQL. The first one was item. The second one was the second one. And now, but there is another way of dealing with this, right? Rather than the kind of like, you know, thou shalt not pass kind of option in the external data source, I can use the query hint here, right? Which is I can actually enable and disable push down at the query level. However, if I have set it in the thou shalt not pass option against the external data source, I can't actually use the hint. So I argue that a more elegant way of dealing with this is actually dealing with this when you have a problem rather than when you explicitly don't want to do that on a specific query. So what I would say is actually it's much better to actually let SQL Server deal with it. So we will re-enable push down against the data source. And then if I really want, and now you can see I'm back to what I would expect on performance, right? But if I then do decide I want to disable it for one query and one query only, I can then just disable it for the query, okay? But to be clear, I could do any mix and match of those tables, right, between those two things. It just limits what we can push down if it's against different sources. What I will say is that we will try and push whole subtrees down where we can, right? So if you have a whole thing where you're doing two joins in that Oracle system, we will try and push all of that down, right, where we can. Okay, it's just depending on what limitations. And now we have a question.
When you say turning off the push down because they don't want you to use it, is that more of a, like, the owner of the data source doesn't want you to do it as opposed to a technological?
Yeah. Yes, it's more of an owner of it. So some systems don't like that type. They don't want you, they want to be able to regulate you more. So that's that. Now, that brings us up to the third and final option, right? And that is what I call the Federated Gateway. And the reason I think this one is the most interesting is because it is an extension of the bottom half of the hourglass and gets you to use SQL in a way that maybe people hadn't thought of in the past. And the Federated Gateway is still the bottom half of the hourglass, but this time we've changed the arrows around, right? So now rather than us querying up, we're actually kind of querying down, right? What we're doing is saying, if you want to access this Oracle system, you're coming through SQL, right? And then you're going to access Oracle. And the reason we're going to do that is to create this consistent hub experience where I can audit and regulate all access, all ad hoc query access to all systems, irrespective of the technology choice that's backing those back-end systems. So your end users have one place to come, one endpoint, and everything else comes through SQL. Now, to do that, I'm going to use, to be able to kind of show the advantages here of doing this, we're going to use some technology, right? We're going to use SQL Server Auditing, okay, which I describe as an oldie but a goodie, because it's been in SQL for a very long time. And we're going to set up an audit with a target and some output. And that comes with a bunch of catalog views. And then we're going to go and query that audit file. But the other thing we're going to take advantage of is a bit newer, is an extension to that, which is the data classification techniques, right? So we're actually going to take our data classification world and expand our horizons here. And there are three key concepts in data classification. There is the discovery, the classification, and reporting. We're going to focus very much into the classification of data. So what we're going to do is flip back into ADS. We're going to open the third notebook. I will introduce you quickly to Oliver, currently the bane of my existence. We're going to create a server-side audit, and we're going to enable that audit. Nothing particularly there. We're also going to create an additional login. I'll explain that in a second. We'll then flip the context over to Oliver and enable the database audit. Now, because we're using data virtualization, we'll create our master key, our database scope credentials, and our external data source. And you could imagine setting this up for an end user team to be able to query their databases. The thing to take into account when I set up that audit is that I have actually auditing all selects through Oliver by anybody. So now I'm going to go and create my schemas, because schemas, and hit the external data sources. And this time we're just going to create the customer table. And we're going to create them both for SQL and for Oracle, right? Now, here's data classification. Data classification, we just add sensitivity classifications. And you can create your own and curate your own so that they can adhere to whatever standards you have in your organization. I've picked the first name in customer, and I've just said, if you hit the first name, that we're classifying that column as PII, right? And you can see whichever ones that you have specified for the org in your database here, all the metadata is captured. Beautiful. Anyone asks you what you're checking on, you can explain that. I'm going to create this database user here, and I'm going to show you why in a second. Now, when it comes to querying an audited table, I can classify all of the columns that are returned. Now, you can see here, we're going to hit customer with a top 10 star, right? So, because of that, we're going to capture that access. And you can just see here that I've got those. Now, if I try to use execute as, some interesting things happen. Firstly, that we get error messages because there is no context mapping back into the remote source. Now, there are some ways to circumvent that, right? Now, the most one that I am aware of is by using the sysadmin privilege. This doesn't exist for like anything other than sysadmin. But if I was to do that, and I was trying to be naughty and try and get through using a different user by creating that, you could argue, okay, so that's fine. He's now done that. What does that mean? Oh, it means that he's now able to run his execute as statement, and you can see that that has now run through using my ad hoc query login, right? So is that an issue? Now, I'm also going to run another query that doesn't hit, it hits our customer table but doesn't use the classified column because I want to be able to show you the difference. And I've also got my execute as query here just in case someone is interested in them. Now when we come into the audit, I use that fn get audit file query to be able to go and get that data. And what do we have? I have every single query that we ran captured. If it has been accessed by the ad hoc query, I actually captured the fact that the ad hoc query user was used versus the infra JRJ user. And for any of the columns that were accessed that had classification on it, I can tell you that that PII person was accessed, that query accessed PII information and was there. Now there is one caveat to this that we don't trigger, and that is we don't audit for like on the where clause. So if that column was in the where clause, it wouldn't be there. But you would see it in other ways, right? So, but I do want to be kind of candid about that. But that does bring me to the end of notebook 3. And I know I'm tight on time, if not over. So, what did we learn? Hopefully, you have learned a ton about data virtualization. You have understood some of the core concepts and how to get started with the technology, what use cases that you might be able to apply and how they might apply in an end-to-end use case scenario, and some implementation insights and what complementary technology exists in SQL Server today that is blended together here. So, session evaluations, please do fill them out. I would ask you to do that for all the sessions that you go to. I want to make sure you re-emphasize that this is a community organization and that actually all the speakers that are speaking here are doing so of their own free volition and are not paid speakers. So it is incredibly important to them that they get your feedback. I'm sure you've heard that a million times, but I really do want to emphasize that. And then lastly, I just want to say thank you to you, everybody, and a special thank you to Wei Yun here, who's from our engineering team, who led all of the efforts to build this tech that you are all getting to enjoy. So special thank you to Wei Yun as well for all of her team's efforts in actually building out the data virtualization feature in SQL 2019. So thank you very much, everybody. Enjoy the rest of the conference.